All right. Well, hello everyone. Happy Thursday. Welcome to Urbit Developer Calls. This is actually our first one of 2022. It's pretty exciting. Um, definitely we'll get back on the cadence of doing these more regularly this year, but I'm excited to kick this one off with Neal Davis, who is the Urbit Foundation's new Director of Developer Experience. Let me go ahead and drop him in here. Hi, Neal.
Hello, Josh.
How's it going?
Pretty good.
You and I met, I think, about the time that you were teaching Martian computing at the University of Illinois. You are an actual professor, not just, the professor of Hoon School. That's kind of cool.
That seems like about the right timeline for it. Yeah.
Yeah.
Fall 2020.
I'm curious. Yeah. I'm curious to know more just about, as a way of kind of kicking this off and introducing people to what it is that we're doing here. If you could tell us a bit about your background and perhaps a bit of your time as a nuclear engineer, which is, I think I know all about one of those. That would be pretty cool.
Sure. So I started, I went to school, started in the early aughts and did chemical engineering. I actually kicked around a little between disciplines. I started as an electrical engineer and then decided I didn't want to do so much math, which in the long run has proven to be absolutely hilarious since I've definitely done as much math. It was just different flavors. And then I took a long, hard look at linguistics and did some linguistics classes and thought about philosophy. I kind of bounced around for a while to figuring out like the thing I wanted to do. And at that point, I was probably halfway through my sophomore year, and I realized that what I actually wanted to do was nuclear engineering, but the university I was at didn't do nuclear engineering. And at the time I was engaged and my wife was going to be starting grad school there. And so I didn't want to switch universities at that point. So I picked the thing that was close, which was chemical engineering. This is like Linus Pauling and I think Enrico Fermi were chemical engineers or chemists are like close enough to it that there was a lot of chemical engineering flavored parts in earlier nuclear engineering. So I did that, and then I switched when I came to University of Illinois and did nuclear engineering. I studied corrosion and surface chemistry of uranium. Ended up doing a little bit of, I did some summer work at Los Alamos about 10, 11 years ago. That was really fun. We got smoked out by a wildfire that summer. It's something else too. I'd never been around that sort of thing. And so standing out there and seeing like the sun glaring down red through the angry smoky clouds was pretty wild.
I'm in California. That's, like all summer.
Yeah.
These days. Yeah.
So I really enjoyed nuclear engineering. The mathematics, the perspective that it gives you on material science, the way that it contacts so many other parts of engineering and systems design and building. One of the problems I ran into is when I finished my PhD and I wanted to work in nuclear engineering. This was right after natural gas prices had cratered, and between natural gas prices going down and fracking, the nuclear renaissance that had begun around 2007 very quickly ran out of steam, and some plant projects were canceled, and some things ended up actually getting built and put in the ground, but it really stole the thunder of nuclear. And at the same time, San Onofre nuclear generating station down in, I don't even know if it's in Orange County or if it's in, it's Camp Pendleton anyway, in Southern California. They shut that one down. And so there were a couple hundred qualified nuclear engineers on the job market at the same time. And so that was kind of a rough time to be looking for a job in a small field. Yeah. So I ended up taking a position with a unit here, computational science and engineering, teaching people how to use engineering software. It was really fun because I got to do all sorts of different things. We got to teach people how to use structural mechanics software, fluid mechanics software, pure mathematical control analysis, process analysis type products. There's a lot of programming involved. You got to do tons of differential equations and teach people how to solve differential equations on big systems and work with supercomputers and cluster computing and everything. And it was really a fantastic way to pick at a lot of the things that were adjacent in engineering. You picked up a little bit of bioinformatics, like it's very much the opposite of a PhD, right? The PhD, the stereotype is that it's
like practical,
T-shaped.
interdisciplinary.
Right. This was right. It wasn't deep. It was shallow, but it was like incredibly broad experience. Mm-hmm. And so I got exposed to a lot of ideas, and this led to ultimately to me teaching computer science in the department here, because the main thing that I teach is computer science to non-CS engineers. And so I teach mechanical and civil, and I teach physicists, and I teach chemists and everything. And we normally teach Python because it's very much just a practical, like, how do you use a computer to solve a problem sort of approach. Mm-hmm. So I've been doing that for a few years now, and probably about 3 years ago now, I ran across the Urbit project because I just like to poke around in obscure projects. And, at the time that was still a very obscure project before the Web3 moniker sort of gave people a way to understand it and carry it around. Yeah. And I participated in an early version of Hoon School that Rapfire Diglight was running with Tlon. And I had a lot of fun learning Hoon. One of the interesting experiences that I had with Hoon, someone else has argued to me more recently that this happens the first time you learn a functional language to everyone. But I had this period where I felt like I was dreaming in structures, right? Like I would like dream in shapes, because Hoon is so formal, right? In the sense of having form, it has a shape, and you can see the backbone of a program when you pick up Hoon. And it was just this really fascinating experience to get deep into that. And kind of on a lark, I decided, so one of the things I've enjoyed about being a professor is the ability to write your own classes. And every now and then you actually get to teach one of these classes. So, you write up a proposal, you put it in, and, if you're lucky, you'll get to actually go teach this thing. So I've taught classes on a few different things in like research methodology and computing tools and some other things, and written a few more that never saw the light of day. Yeah. But, on a bit of a lark, I thought, like it would be really fun to like actually teach kind of the mathematical technical side of Urbit, because there's so many fascinating ideas that are folded into this project. Some of them are necessary, right? Like you don't have Urbit if you don't have Knock. Yeah. And others of them are interesting ideas that no one's tried anywhere else, but they're not like inherently Urbitish in a sense. Things like the loom, right? The structure of the runtime. You could imagine very different runtimes that accomplish the same thing. And so, but it's just this grab bag of all these really fun ideas that, and at worst you can say they're 1990s ideas about what an operating system should look like. So I wrote it up, I put it in, and to my surprise, they approved it. And so in fall 2020, I got to actually teach it with some grad students and run it there. And that really cemented me in thinking in the Urbit sphere, right? Because I had to get very deep into the kernel and reading the source code and get comfortable with everything. Because if you're they say, right, one of the best things to learn something is to teach it to someone else. Yeah, so I had to live that, where I was just drilling deep into it all. Yeah. And so, since then I've done a few other minor projects here and there around Urbit, and then
you've been all over the stack, in your contributions too. So, okay, great. Well, that was a excellent introduction. I know another area, at least that you seem to be a specialist in, is engineering pedagogy. So, not just, but the actual practice of teaching something very technical. Mm-hmm. I know you have a lot of thoughts about the right way to teach and the nuances of that. I'm curious to hear more, just a bit about your philosophy of teaching.
I should have grabbed my pile of books. So what happened when I was in grad school was I started to form really strong opinions about the way textbooks were written. Because you see so many textbooks and you get to compare them. And sometimes you take classes that are similar enough that you actually see textbooks in the same topic by different authors, and you start to get at least I did. I started to get really strong opinions about like what is the right way to write a textbook, and this kind of
And
ended up pivoting over. Yeah.
And there are some textbooks that are really just, amazing. Like I have, say, over structure interpretation of computer programs, I think is right there, which is one of my all-time favorites. Yeah, they're definitely not all created equal.
Right. And so some of this was, I think what was really driving me nuts at that point was how good the technical apparatus was. Like how good your indices and your equation expressions and everything are, because some books, they'll give you good equation summaries, or they're very interlaced, where you can find the previous equations that you need because they actually make reference back to numbered equations and everything. And some books are just like, they just keep presenting new things, and it's really hard for you to keep track of like what's actually going on. So I think that was the thing that finally triggered it. But it ultimately turned into a deep interest in teaching and pedagogy, right? So pedagogy is the idea of how do you effectively teach someone how to understand a concept. And the challenge of pedagogy is, well, there's a lot of challenges in pedagogy. One of the challenges in pedagogy is the Meno paradox, which is going back to Plato. And this is a dialogue where the Socrates authorial cutout for Plato invites a slave boy over and starts asking him questions about the shape of a square and what happens if you cut a square a certain way. And all he's doing is asking questions, and he ends up proving that this boy knows how to do fairly sophisticated geometry. And the problem that's presented by Plato in this dialogue is essentially like, where does knowledge come from? Right? Like, how do you actually give knowledge to another person? Because here's an example of Socrates giving someone knowledge when he never actually gives them knowledge. He just asks the right questions. And so it's actually a really philosophically fraught question to start talking about, like, how do you teach someone to do something?
Yeah.
And then there's the flip side of it, which is what the credential heavy institutions like mainly universities get concerned about, which is how do you tell whether or not someone has learned the thing that you're trying to teach them, which is also an extremely difficult thing to do. There's a lot of work that's been done on what they will call concept inventories, a lot of certification processes. So if universities have their certifications, but programs have certifications as well. And these come from various kinds of trade boards and industry boards and various guilds and everything. And what they're trying to establish is that everyone coming out of the program can perform to some level of capability. And you have to do this without scaring people off from your program, right? Like, you sort of can't ask the hard questions up front because you don't want people to just throw their hands up in the air and give up on actually learning the thing that you're trying to do. So you're trying to figure out what they know without like breaking their will to go on. And, obviously, there's a huge range of kinds of people that learn things. So it's not like this is common to everyone, but it's one of the things you have to keep in mind. You want to know that they are actually understanding the idea rather than cargo culting it, where if they go through the right forms, if they go through the right incantations, have they still built a bridge at the other end of it? Well, I'd like to know that they actually did understand stresses and trusses and how these things lock together, not just that they knew how to draw the right shape on a piece of paper and transform the right linear algebra matrix, and if it magically comes out correct, then they understand it. So this is a really hard problem, and it reaches deeply into like, you have to be able to present ideas multiple times in multiple ways. There's a lot of different modalities of teaching that you need to make accessible to people. Some people learn better reading things. Some people learn better from videos. Some people learn better from live lectures. Some people learn better from interactive exercises. And you want to expose people to all of these things, because doing it more than once, the thing they used to tell us about chemical thermodynamics was until the seventh time we saw it, it wasn't going to stick, right? It wasn't a thing that was going to stick with us. So being able to formalize everything in an engineering sense means, in terms of engineering pedagogy, means that you have the concept inventories, right? Like, the things that you're trying to teach people. And what you do then is you work backwards from that. So you know what you're trying to teach people. And then you are trying to design assessment mechanisms that demonstrate whether or not they actually know this. So in a classic class, this would be your final exam, right? This would be them walking away and saying, like, I've got this grade. It means that I can perform at this level of capability.
Yeah.
It also means homework and other kinds of things, right? But there's actually two ways you assess. One is what they call summative assessment, which is when you're actually trying to peg what is the real performance at a given point. And the other is formative assessment, which is more like what Socrates was doing, which is saying, by asking these questions or trying to force you to think about the next step in a particular process, can you teach them how to understand this concept? Mm-hmm. And so what you end up doing is you end up working backwards from, here's my concept inventory. Here's the formal statement of my learning outcome that I want the students to have, to how do I know if they have it, the summative assessment, to how do I teach them to have it, the formative assessment, to whatever your content is, right? Whatever your lesson. And so you can build this pipeline, but the funny thing is you have to build the pipeline backwards if you're doing it properly. Mm-hmm. And of course, learning is very path dependent. And so even once you've set this up, you have to take into account the fact that they're reading different elements of your lesson materials. They're encountering your formative assessments in different orders. They have different understandings coming into this different ways. And so there's a lot of moving parts in this machine. And that's one of the things that makes it really fun when you're actually trying to build and design a system.
Yeah, absolutely. Okay, well, that was a great explanation. And I'm curious to know now, okay, so that's your background, that's your philosophy, and now you're teaching Hoon School live. What are you applying from your background, and what are you going to be doing differently, or with the approach to Urbit education, both in relation to how it has been done in the past, and perhaps in relation to how other technical projects may be taught?
Mm-hmm. One of the advantages I have here is that I can stand on the shoulders of giants doing this, because it's been taught a number of times by different people in different ways. And so there have been a lot of things tried, and we can see what works, and we can see where
you've tried some things too.
And I've tried, I did the grad class
assembly and the grad class,
and assembly.
Yeah.
And so if you go back to, the original Rapfire Diglight ran it a few times, and then it was taken over by the Hooniverse group, Rabsef and Rick Russ and others, and taught several times by them. And I think that, there is a natural evolution in which Urbit Foundation, now that it exists, comes to own the space of education in a way that I think we can continue to throw resources at it in a consistent way. But we've seen how it was taught in different orders with different kinds of projects, and we can sort things out a little bit from that. One of the things that I did that I think is, let me switch to the slides here.
Mm-hmm.
Let me give you the blank version here. So I posted this on Twitter a couple times, and it's kind of this snarl, and I don't want to scare people off by looking at this snarl, but like, this is Urbit, okay? This is Urbit.
Yeah, it's a little scary looking. Yeah.
What the main thing that what this does is this basically breaks down every part of the entire project from what is a rune to how do I push a production over the air update and it goes wrong and I troubleshoot it live, right? Which, we have ton engineers who have to do this. So this is looking at every part of this process. If I'm digging around inside of the veins like clay, one of these is the description of clay at a technical level.
One thing just to flag, okay, so this looks a little bit frightening, but the other thing to remember is this is the entire system. Like, that's all of it. There are probably many systems where you just couldn't even do this in the first place because you don't even know what to put on the page.
Well, Linux binary blobs is always the thing I point out in this connection, especially to open source folk.
Yeah, it's a lot, but it's
right. But it's if I color code it here, it looks a little bit different. I'll post this somewhere that people can look at if they're really interested in getting into the nuts and bolts of this. what every one of these nodes represents is a set of competencies, right? So if I were to look at one of these, going off memory, something like 183, which is the one in the middle here. Let's see. I think I actually did have a pen. Yeah. So 183 here. You'll notice that there's a lot of arrows coming into it, which means there's a lot of things that depend on it. And if I recall correctly, 183 is managing state. It's either that or 180 is managing state. I'd have to go look these up to be sure. But, there's a lot of dependencies on these. And it turns out that once you know how to do certain critical things, the reason it's a snarl isn't that you have to go do a bunch of things. It's that once you know one of these critical nodes that a lot of arrows come into, you're enabled to do a lot of other things, right? So you can spend your whole life, you know how Arvo works, and you're going to spend your whole life in Gall. And so Gall are the orange hashed ones like 230 and 280. You can spend your whole life in Gall and never touch a lot of other parts of this system here. So I don't want to lose people on that, because if you want to know how to build a production Gall agent, I think it might be 480 here. This is like looking at producing a Gall agent with a glob and a front end. That's something like PALS or Escape or Landscape, something on that tier of capability. One of the things we can do is, because we know how these things relate to each other now, both from teaching it before and then from doing kind of a deep dive through all of the docs and the files and figuring out how these things relate, is that we can tell you what your critical path is. Yeah. So if you want to accomplish something on Mars, and you can point to it on this chart, we can tell you exactly what to learn and what would be off the path for you, right? It's not saying never go learn how air and iris work or how jail works. It's saying you probably don't need to know technical details of these to do what you need to do. You do need to know Hoon, right? This main arc up the side over here, this is what I call the Hoon backbone. And this is what Hoon School is going to be built around, right? So Hoon School are just these colored parts here. These are the lessons that we're covering with Hoon School. And so once you hit these, you hit something like 180, and 217 is distribution. So I'm actually cheating a little bit because it has other dependencies, but it's like, how do you distribute a desk? Once you know this backbone, then Urbit is your oyster. Right, you can go work on kernel level operations. 201 is Arvo, and then the veins that depend on Arvo. 201 is Arvo as a state machine, right? Like if you're starting to think about like how do I send moves, and I have a card and a bone, and what do these things mean, and how do they interact with each other? Once you know Hoon, once you know the language, you're able to go do that. You're able to turn around and just go to Gall and just work on Gall applications. You're able to go work on like ETH Watcher, Azimuth style operations. So that's this cluster down here is working on Azimuth. That's why it has the Solidity EVM dependency, because of the ecliptic contracts. And so we're going to be able to take any one of these and answer the question for you in the docs of, given that I want to accomplish, productive task X, what are the preceding things that I need to know how to do? And of course, if you've been poking around this environment for a while, you probably have a lot of spotty things, right? Like, how to do some of these components really well, but some of them are missing, right? Like you never sat down, say, and learned how a Tizcat worked in great detail for whatever reason. So we're able to tell you, okay, we also know like what's missing in your path dependent approach to Urbit. And what this looks like. And one thing I didn't put in these slides, and I should pull up here, is what these lessons actually look like, what each one of these nodes looks like. And so I will.
Is this in the curriculum repo?
It's in the curriculum repo, but I'm actually going to switch my share and
okay, cool.
Share that tab. All right. So there's a Sigilante /curriculum repo that
I linked it a little bit before.
So in the lessons folder, these are a bunch of YAML files. And so if you click into one of these, then you can see this is exactly what we're thinking about is, that node 183, the title is sets, maps, jars, and jugs. All right. So the objectives for this are, can we identify units, sets, maps, and then jars and jugs, which are like a set of maps and these sorts of ideas. Make sure people understand why we use units and why we use vases, right? These perform a very specific role. And then there's some helper arms and syntax. And I think this first one might have gotten eaten. No, that's a tick. That's why. It's because trying to display.
It's a tick surrounded by ticks.
Yeah. Okay, so the problem, I picked Markdown, or I picked YAML as my language for this. And the problem that I ran into actually is that tick is a reserved character in YAML. And so you run into like this double problem of you're trying to store a tick inside of Markdown ticks, but tick is also a YAML reserved character. So, it's as bad as like HTML where you just switch back to the semicolon representation for parentheses because things don't work. So, people, if they want to, they can kind of trawl through this. I'm trying to do all this as transparently as possible because I want people to dig into this. So 245 represents con, which actually hasn't been pushed yet. So this is a placeholder, right? I don't really have details about con. I've read the docs and everything, but it's going to have to mature a little bit before we know how to answer this question for people of like, how are you going to use con in an effective way? Right?
Yeah.
So whenever
at the very least, it needs to get merged.
Right. Whenever the next runtime gets pushed, then we'll be able to get into more depth there. So some of these are far more detailed than others. And there's actually also a chart. I think it's, curriculum raw CSV. And this actually has a summary of all of these.
Okay, cool.
And I think if you scroll to the right, it also has what the dependencies are. So that's how I built that.
Okay, this is how you build it. Yeah, exactly.
And so the basic idea that we're aiming for at all of this is that we know enough because we've taught this a bunch of times and various people have taught it, that we can start to answer the question of, what do we actually need to teach people to get them effective at working with Hoon? So for instance, I think one of the changes that I've made in Hoon School Live this time is that I'm talking a lot about state like Tizket and how we pin and alter state in a functional language. I'm not talking about core like lead and gold and iron cores. And I'm not talking about wet gates and dry gates. Everything we're doing is dry gates. And it's not that these things aren't extremely valuable, particularly when you start doing fancy things and sophisticated things in the Hoon parser. It's that I think arguably to some extent, the way that the docs have been constructed has been built around the idea that Hoon needs to bootstrap itself. It needs to be able to parse itself. And so parsing is this huge focus of the docs. Whereas for most users of Hoon from henceforth, parsing is not going to be at the top of the list of things that they're concerned with. And so knowing how to plug in a wet gate right now, I think is not a critical backbone part of getting them to working on Go.
Yeah, I mean, the Hoon School docs, I think, are probably going on about 4 years old,
right?
At least, which was long before anyone was really developing applications at all. So they were at a time when, the main pathway was contribute to Urbit itself, because there really isn't anything to build with Urbit because Urbit still needs to get built. So I imagine, a lot of what we're dealing with Hoon School is a legacy of, well, it predated the time that people had a productive use of Hoon, which is, go out and actually build software using Urbit.
Right. You needed desks, you needed distribution.
Yep.
You needed guides, right?
You needed landscape, you needed proof of concept that you can do this and everything that went into making that possible.
Right. Humans love scripts, right? Like it's really, really hard for us to do something genuinely new if we don't sort of have something, some idea of how we're going to get to the end of it. And as more and more demonstrations of the kinds of things that you can do with Urbit are made, we're going to have people building more and more new things.
Mm-hmm.
And this is fantastic, right? Like this is the way it's going to work. It works for most people, right? Most people aren't trailblazers because trailblazing is a costly and high failure kind of activity.
Yeah.
Right. There's a lot of universes in which Urbit never succeeded.
Yeah.
Right. Like it was
Thankfully,
too
we're not in
weird.
that one.
Right. But it was too weird. It was too, I mean, you look at like other alternative computing concepts and ideas that have been out there. I mean, we go back to Ted Nelson's Xanadu, go to like the mill computing architecture. And it's really hard for some of these innovative ideas to actually succeed rather than to just, have other people come and pick all of their best parts out of them after the fact. Right. I mean, that's kind of the trailblazer idea there as well. Anyway, back to the docs, right. I think the docs were written with a certain kind of application in mind, which was future Tlan developer.
Yeah.
Because that's what a lot of what Tlan developers have done. And that's right. And that's just, but I think that now as we're running Hoon School Live, I think it's an opportunity for us to rethink what we're doing with the tutorial level docs of how are we onboarding people into the Urbit system.
Mm-hmm. Mm-hmm. So let's talk a little bit about, Hoon School Live and what it's going to be like, the format. Get into the specifics a little bit because that's coming up and it's pretty exciting. A lot of people are excited. What's the enrollment is?
Yeah, let me see what the
What
enrollment
now?
is as of this morning. It is 199. Someone signs up, they will win a free beer cozy in the next 5 minutes.
Let's get to 200. I mean, okay, that's
operators are standing by, folks.
Yeah, seize your chance. This is probably a record for Hoon School enrollment, which is awesome. So tell us about what it's going to be like.
Well, I mean, part of that's because Hoon School hasn't been run in a year.
Yeah, true. There's a lot of
there's a backlog.
Pent up.
One of the
they're
things
still waiting around, so that's good.
Right. One of the things we're going to have to
bounced by
figure
now.
out as part of foundation educational initiatives is what is the right periodicity for running Hoon School,
Mhm.
right? Like if we ran it every month, I imagine we'd have 5 people.
Yeah.
But if we run it twice a year, is it so there's going to be a crossover point there. Okay, so what we're doing with Hoon School, we are going to start next week with what I'm calling a session -1. This is because session 0 has traditionally been our how do you set up a fake development chip on Urbit, and how do you make sure your operating system is doing what you need to. If you can run Urbit, I'm actually gonna have to go dig around and can we do a fake ship in port, for instance? I don't know. But making sure everyone has like a working development environment that does what they need has been our session 0. I'm going to start with a session -1. The idea being explaining what we're doing with computing, big picture, for people who've never programmed before. So I'm voicing Hoon School towards intelligent beginners, right? We're not going to assume that you've programmed, and we're going to try and explain everything. I'm going to use analogies to other languages where I have them at hand, but I'm not going to rely on anyone knowing any particular language or really knowing programming in a thorough way. Just that we're going to do it. We're going to do a quick intro of like, what is computing? What does it mean to have a computer or to carry out a computation? What does it mean to represent code and commands and values and addresses and all of these things on a computer? How do they interact? And then ultimately, like, sort of, how does this tie into what Urbit is, right? One of the problems in the past has always been explaining to people, right? It's kind of hard to have an elevator pitch for Urbit because it's so many things. But I think one of the core ideas that I'm going to try and do with the session -1 is give people an idea of like why every part of Urbit speaks to like what we necessarily need in a computer, right? At the level of, Azimuth is carrying out a key role in identity. And when we talk about Urbit OS, Arvo was doing a key thing in thinking about and working through this. So that's the way that we're approaching that. We're gonna teach these. I'm going to be teaching twice on Thursdays. I'm going to do an 8:30 a.m. my time, Central Time, and an 8:30 p.m. Central Time. And then I think it's Wickrun is going to do a European time on a week delay from the same content for if we work out the details of what that's going to look like. I'm going to be teaching and talking through a live lesson. So it's basically going to be a live stream, and you'll be able to ask questions to me. Participants will be able to ask questions as we go through it. I'm aiming for about 45 minutes of content and about 15 minutes of Q&A. So we're aiming for about an hour of actually doing this. I want a lot of this to be live coding, and I want people following along to have their hands on the keyboard, because there are a lot of nuances to programming in Hoon that you have to get used to. For instance, there's a difference between a space and anything else, right? There's a single space, which means one thing, and then there's double spaces and triple spaces and line breaks, and these mean something else collectively. And until you start typing Hoon code, it's hard for you to get a feel for what the difference of those things is. Right. If I'm thinking back to what I was learning and doing in 2019 with this, like there were definitely issues that I ran into in trying to reason through this. And there's a lot of pieces where we have runes that do almost the same sort of thing, like a tisfaz and a tislas. And I'm gonna try and flatten a lot of that into like there's one true rune to do this process, right? Which isn't saying don't go learn the other runes later, but I'm going to be much less concerned with getting you a completist view of.
It's best to learn the fundamentals before learning how to refactor your code for optimal flow and appearance.
Right,
which is what a lot of these things do. Yeah.
One of the ideas that I had early on was that we could probably teach people about 25 runes and get 85-90% of the capability of Urbit covered by that. And I continue to think that that's true, that if we teach people, basically what I've done in the past is I've just grepped the source code, which of course misses irregular forms and everything. So it's not a great way to do it. What I should do is I should get the abstract syntax tree of every file and then search for all of the tokens of every rune in that. And then we actually do know the real frequency of senheps and all of these things. But it gives you a good heuristic for like what are the things, right? It would. What are the things that people are actually using in code? So it turns out too that if you go poke around, there are some runes, they're in the docs, they should be in the docs, but they're literally used in the code base once or twice, right? And maybe they were used a lot more previously and they've been overridden, or maybe they were created for that one specific purpose. We needed a more elegant way to express something. And so, those are things we don't need to talk about, right? We don't need to get into those.
Yeah.
So I'm gonna try and teach it that way, and we'll see how well it works, right? I'm fallible. No lesson plan survives contact with the classroom, so we're gonna try running Hoon School this way, see how well it works, and we're gonna iterate forward and try that approach. So we're gonna spend time on Hoon syntax, key ideas. We're gonna spend a lot of time on cores, which I guess cuts a little bit against what I was saying earlier about we're not going to talk about lead and iron and wet gates and all these sorts of things, because that's
you're going to tell a white lie. It's just going to be cores, and you're not going to know which type of core it is, right?
Right. Everything. And they are cores, right? Like it's a super category. But one of the things that Urbit gets you for free that I think people who haven't done a lot of Hoon do not yet appreciate is that because everything has an extremely consistent structure, you are able to start making a lot of assumptions about how you use and manipulate things. In an object-oriented programming language, if I'm doing C++, if I'm doing Python, if I'm doing Rust, I like to say, it's an object. And so this has certain guarantees for me. Well, a core is the equivalent notion in Hoon and in Nock, right? Really. And once you get what a core is and what it's doing, and the fact that every core has the same structure, and this is a guarantee, right? This is the way Nock works. Then it will speed up the way that you're able to think about and produce code enormously. Setting aside static typing compiler issues, which are extremely valuable, right? They're very frustrating for people, but they're very valuable. I have found that by the time I get to working code, by the time I can build the file, it's almost 90% done, right? Hoon is an extremely fast development language. And the strangeness of working with runes of largely ASCII-based structural phenomena, I think puts people off the scent of that a little bit. But that Hoon is a fast, valuable development language. And because you get all these things from the operating system in a consistent, principled way, you don't have to worry
Urbit
about
is unique in that
right
capacity, really.
Right. So let's say you want to get a random number on any other system, and you actually have to do it at a low level, right? So you're probably doing something like you're reading off slash dev slash random or dash u or slash u random, right? Or you're pulling out some there's some C functions, there's boost, there's a zillion places for you to get random values, and these are of greater and lesser quality to you, right? So going, harkening back to engineering, in scientific computing, it actually matters enormously what your random number generator is, because when you start doing Monte Carlo quantum computing calculations, if you don't have a high dimension enough random number generator, you start to see hyperplanes where values aren't occurring. So it's like a 600 dimensional space, but you're only seeing 599 dimensional random numbers. And this will actually strongly bias your results. And it's something that's extremely hard for you to figure out and tease out. I'm not saying whatever Urbit is doing for entropy is that quality of thing, but I'm just pointing out that because you have so many options available to you on a traditional Unix-like operating system, you can end up in all sorts of difficulties in processing the kinds of things and the kinds of affordances that exist. And so Urbit guarantees that you have certain affordances. It may not be the most efficient programming language or programming platform, development platform, because of fundamental limitations in knock. It may not be the most provably correct in the sense that we don't currently have jet proofs and may never decide that that's valuable. But barring those sorts of binary level runtime issues, we get a lot of things for free. And now that we can run software on different desks and we can reach into different desks and access their information the way that Escape does with Landscape, then we're going to be able to build all sorts of new things on top of these shared primitives. Yeah. Right? This is this huge value add that people who get Urbit are seeing, and people who don't yet get Urbit are missing.
Are focusing on runes.
Trees. Right. They're missing the forest for the trees. Yeah.
Yeah. Exactly.
Like you don't even see runes, right? Right. It's like the Matrix thing, right? I don't even see the runes anymore. I just see the structure.
I mean, this is true of every programming language. Anti-Lispers complain about parentheses, and Lispers don't notice them and think they're generally a huge asset because they lend a certain amount of regularity to their programs that they can reason about. But with any language, once you build familiarity, which is basically a finite amount of time that it takes a programmer to learn how to do any given language, the specifics of that language fade into the background, and now you're just working with the domain. Right. And Hoon is really no different than that.
Well, and I think there's a related, because we have this curriculum map, right? We can also think about questions like, let's say we want to quickly onboard front-end developers who don't want to learn Urbit internals. What's their shortest critical path? Right. We can answer. I think we can answer that now if we actually sit down and think about it. I think we have enough information to answer that. I don't offhand know the answer, but it's a good question, and it's one at some point we should explore. I don't think that's on our bottleneck right now in producing things in the Urbit ecosystem, but someday it probably will be, where we need more front end devs who can just they can slap together a JavaScript and HTML page that talks to a Gall agent on the back end. What do they need to know to actually make this work? So we can get into those sorts of things. So I'm excited to see where Hoon School goes performance wise. We got a couple hundred students involved. We've got some good TAs. I'm not intimidated by the size in this case, because I normally teach hundreds and hundreds of students, and because it's a state school that I teach at, right? So I'm used to grossly large classrooms, so we'll be okay there. But one of the interesting, right? So there's a rule of thumb in teaching, which is that your as the instructor, your enthusiasm level is the ceiling for enthusiasm in the room. Right. And normally that's true, right? Like you have to inject an enormous amount of energy if you're teaching a large class, right? I used to
Sure.
liken this to, it's like yelling at a TV with the static turned all the way up. But I think that this may not actually be true for Hoon School. I may not be the ceiling of enthusiasm, because we've got a lot of people who are excited about doing this and learning how to Hoon and then building things on Urbit. So what we're aiming for coming off of Hoon School is that you will be able to step into Tennis's Gall guides and start building things immediately. That's the off ramp for Hoon School. So we want you to do Hoon School, and after Hoon School, you can step into the Gall guides and build. That's what we're. That's what
the Gall pathway in your, in your diagrams here is much smaller than the Hoon one, right?
Yeah, Gall. So Gall is this orange hash here, and so it's kind of this cluster right here. This is
Plus a few other disjointed ones.
Vein, and then this. So the upper one is 230 and 280 are the technical vein, and then this one down here is basically building apps. So one of these is Spider, which is the thread handler, and then. Anyway, that's what's going on with Gall. Is basically how do you build an agent and talk to it and keep things going. Yeah. Right? So Gall isn't big.
So
right?
in comparison, you're like, compared to what you're going to learn in Hoon School afterwards, learning Gall is, there just isn't that much to learn.
I mean, it's a little bit of an illusion because it's not like all of these nodes are the same size.
True.
Right. They sort of represent unique clusters of things, but that doesn't mean they're commensurable in terms of what it would actually take to learn and master that content. But that's just a deficiency of representation. It's not one we can get away from.
Yep. Okay, we've got a few questions that we should answer real quick.
All right.
Because, it's funny, before this call, Neal was saying, I don't know if I'm going to have an hour, of material to talk through. And, here we are nearly an hour in. Not surprised. A couple things. Should boobs apply?
Should what apply? What?
Do you expect different results from different levels of starting capacity? Should the noobs apply? Is what that is supposed to be.
Yes, I'm comfortable saying that. And if we have to, I don't think we should have to double up into 2 tracks, like a noob track and an experienced dev track. I think we can do all this as 1 track. So I'm used to teaching a mixed audience, right? So when students come into my big class that I teach at University of Illinois, about half of them have had prior programming experience and about half of them have not. And by the end of the class, I don't see a significant difference in outcome.
Okay,
so
cool.
I'm aiming at, the answer to this should be yes, and I'm aiming for it to be yes.
Good. And we have actually quite a few, practical examples of this outcome happening in past Hoon schools. For instance, this guy, Eric, was fairly new to programming, nearly completely new. If I remember correctly, I think it was just Visual Basic before he learned Hoon, and then eventually went on to actually teach the course. It was a pretty short turnaround, which I've always found pretty impressive.
Well, one of the advantages of that I know Eric has commented on is having beginner's mind, right? Where there are certain advantages when you can connect to learners because you're just 6 months ahead of them or something, right? Maybe we can mitigate that with the TAs some. We'll see. We'll work it out. Definitely. It'll be okay.
A couple other things. I think this is a pretty quick question. Haven't received any further emails after the sign up. Is anything forthcoming, or are there any missed communications?
I haven't sent any emails yet. Get in,
okay,
join the Hooniverse group. I will send an email. I'm very good at having one thing on my mind, and this has been on my mind. So I'll look at actually sending emails after this dev call.
Yeah, and definitely get in that group. If you don't have a planet yet, get in as a comment and ask for a planet, and we'll make sure you get one. Because now that's actually a thing we can do without having to spend, boatloads of money, which is pretty cool. Okay, a couple things. want to go through this one real quick. This is a good question. Professor, what is your conception of Urbit and its future? And how do you view the project? What drew you to it?
Oh boy. Oh, okay. So I guess I'll answer the second question first, right? Or the third. How did I get drawn into this? When I got involved in Urbit, it felt like a treasure box, right? It felt like a puzzle box where you could keep messing with it and discovering new and interesting things, right? Like it was simple enough that, like, mechanically simple, in the sense that you can build on Nock, you can build Hoon on Nock. It was mechanically simple enough in the sense that you could understand all the parts of it. And the kernel's short enough that, like, in principle, you could master the kernel. I don't consider myself to have done that, but you can definitely crack it open and understand it at a level that you can't understand, say, Linux, or even some of the teaching operating systems like Minix. So I really enjoyed that aspect of it. And I think that was the thing that hooked me, was this ability to sort of always have new and interesting corollaries. And there's a lot of parts of the system that are necessary. If you go back to Wycliffe Wistreit's Urbit precepts, then he's trying to write out a philosophy of why Urbit looks the way it does. And there are parts of the system that are necessary, right? That they have to look the way they do, like almost in a mathematically precise sense. But then there's a lot of other parts of the system that are contingent. There are things that someone did it this way, and it's held together with rubber bands and duct tape because they had to build something to solve some other problem that they had. And so there's also kind of a game, and anytime you look inside the system, of figuring out which one of those you're looking at.
Yeah.
When you pull this up. So I've enjoyed it. Like I said, I would say aesthetically, right? I found it compelling. Now, what is Urbit? What's its future? Why does it matter? It's a bigger question. One way that I'd explain this is that I think that for humans to continue to build new and interesting subcultures, right? Subcultures is the driver of cultural production. You have to have the ability for humans to sequester themselves meaningfully from the larger noosphere, right? That you have to be able to have a cloistered group of thoughts where people can work deeply on problems without getting caught up in broader cultural discourse or cultural demands. Right. I don't think you win humanity without that. This is, in some ways, this harkens back to ideas about monasticism, right? Or certainly what the university looked like before the 19th century, where essentially that's what a professor was, right? He was sort of a dedicated monk of the mind, doing particular things, and he actually had holy orders, right? Like he wasn't secular. And for a lot of reasons in the cultural West today, this is blown up. And I don't think we recover it on Twitter, right? And I don't think we recover it on Discord. It's too reliant on other people's ability to, or capability to intervene on what they're doing if they disagree with what you're doing for any reason. I mean, there's a lot of valid and invalid reasons for that the system sees for intervening on finances, for instance, right? Some of them may be tax related, some may be ideological, some of them may be sheer incompetence, right? I mean, I like Urbit for the same reason that I like having a well, because it means that I don't have to rely on a bigger outside system. There's a trade-off there, right? I mean, I'm still going to use Google to search for things, at least until the algorithm finally bites the dust, as it's been gradually doing over the past decade. But having the ability to have a place to retreat to is really valuable. And so I think long-term, I've been writing a little bit about this, and I'm going to put this out there soon. The legacy internet, I think of as, it was originally a high trust environment, and over time it became a low trust environment. And now it's essentially a zero trust environment but deceptively, it still advertises itself as high trust in some ways. And so you see this with, for instance, Twitter mobs. So it's very much like kind of this escape from New York, Mad Max style player versus player interactions, where there are a lot of transient coalitions of necessity that arise, but at any point you could be shut out of that discourse. Whereas being on the internet should ideally feel more like being in a village, right? Where you live on a village, you have a village green, you have a commons, you interact with maybe a couple hundred other people with whom you have high trust, and you have stable relationships over decades, perhaps over lifetimes, over generations, right? Like maybe my kids will know Uncle Eric, right? Uncle Rabsep, right? But
Yeah.
the idea being that we need to turn back the atomization of society that's taken place with the way the World Wide Web has been currently structured. And of the options that are available to do this, I firmly believe that Urbit is the only one that's viable. Anything else that's trying to do what Urbit does is at least a decade behind Urbit in terms of development. And the things that need what Urbit do, like DAOs, decentralized autonomous organizations, are just now starting to wake up to the fact that they need something like what Urbit provides. So I think Urbit, it didn't have to be the thing that solved these problems, but it is the thing that solves these problems. And there's not another thing coming along to save us, right?
It started solving these problems literally decades ago.
Right. You build on this because this is what you've got. Like JavaScript sucks, but everyone builds on JavaScript. Urbit doesn't suck, but you should build on it.
Yeah. Okay.
All right. What do we want to do here?
Well, so that was great. We've run out of questions aside from, Uncle Eric's question about teaching dynamic Gaul as archaeology someday. The answer to that is probably someday. Oops, this one.
Someday when the Hooniversity has a physical campus in Austin, Texas, we will teach the proto history of Urbit.
Yeah, exactly. That's actually a likely outcome. Is a campus in Austin at this point. So I think at this point, what we are going to do is what we usually do at the end of these, which I didn't announce at the start of this. So if you haven't been on an Urbit developer call in the past, then, sorry, I didn't give you a heads up. But normally what we do after this is jump into a Google Meet link. Still Google for now, unfortunately. But the thing works where we can actually all just hang out, ask Neal some questions in person. So I'm going to go ahead and post a link to that. We still have 2 minutes. Here's another question. What is the main difference?
What is the main difference of what? Oh, I see.
A lot. There's a lot of differences.
So I think what I would answer is that Web3 is a concept that has emerged particularly driven by the smart contract, smart chain community to describe the set of technologies that aim at decentralization and aim at getting away from some of the local maxima that Web 2.0 fell into starting in the aughts. Getting away from
particularly
the and these sorts of things.
Yeah, particularly the variety that surrounds blockchains, but not necessarily. Like usually that's what people mean when they talk about Web3 and decentralization is around blockchains. Now,
there's a Venn diagram between them, but
yeah,
they aren't the same.
They're not the same thing. Decentralization has been being worked on much longer than blockchains have been around. And Urbit is one example of a project that actually started before a blockchain existed, was announced around the same time as the first one existed, and has been, functional on a live network since I think like 2012, 13, somewhere in there. Anyway, let's if we want to follow up on that line of reasoning, everyone can go ahead and jump into this link right here, which is where we're going to go and hang out for, at least another half hour or so. Drop in, ask the professor some questions. Thanks for coming, and we'll see you at the next developer call.
All right.
Thanks,
Thank
Neal.
you all.